Data collections are a container in memory that contain a group of objects. We've already seen the array, and we've also experienced the item's property in several controls, such as the image list, the list box, and the combo box. An image list, for example, lets us contain multiple images. A list box contains multiple string values that are indexed, and same with the combo box. We also have collections, though, that exist in other namespaces, such as the system.collections. We have an array list, hash table, queue, and stack. And then also in the systems collections.generics name list, we have generic collection classes, such as list, dictionary, queue, and stack. And then there's sorted list and sorted dictionary and a few others. These are the most common data collections. The ones from the system collections are not typed. They all just contain objects. Whereas the ones from the system collections generics namespace are strongly typed, and we specify the type of data that they contain. Most programmers prefer using strongly typed data sources because it often means less errors and less potential problems that have to be covered. We've already looked at arrays. We're going to look today at ArrayList and list. As you recall, arrays were statically sized. We could create an array of a specific size, or we can create an array with values that then auto-sized it. But we couldn't change the size of that unless we redimensioned it and used the word preserve, which would keep the values that were there and allow us to resize the array and make it larger or even make it smaller. And that's kind of unique in Visual Basic. Most languages don't allow you to resize an array. However, it's not efficient because what happens there is it takes the array and creates a new array and copies the values from the old array to the new array with the new dimensions. That requires quite a bit of processing on the computer end. Now, it does this typically in a split second. However, it's not an effective way of managing the memory from the computer's point of view. An array list, though, is a dynamically sized array. It automatically shrinks and expands as needed. And it can do that more efficiently than an array because it's not making a copy. So we have to create the array list as a new array list. It's an instance of the array list class. And we can then add values. So I can say myal.add. I'm going to add a string of kangaroo, but I can also add an integer value, myal.add 25. If I wanted to add a group of things, I can create an array or some other type of collection. In this case, I did an array called temp as integer equals a group of values, and then myal.addRange, and I pass it that collection, and we'll add those into my array list. So there's lots of different methods for working with arrays. As I said, they're dynamically sized, and we can add and remove and add ranges and insert values. And there's a sort property with an array list. And in some cases, the fact that it's not typed can be an advantage because it stores everything as an object. So I have mixed data types in an array list. But in most cases, we consider that a disadvantage. It can create some problems. So on the negative side, we have that array is not typed. It's also slower than the next data type we'll look at, which is a list, because it does something called boxing and unboxing, in that it has to figure out the types of those objects within the list. Array lists typically aren't in other languages, and it's an older technology versus the list, which we'll look at next, which is newer. And generally, let's face it, things that are newer are usually better. And it's not multidimensional like an array is. But we can use structures and classes as type instances, which is probably better than using multiple dimensions in collections. Let's take a look at an example of an array list. I created this little demonstration to show you how the array list can resize itself. So I started by creating a class level array called myal as an array list. Then I created a temp array of various integers and added that temp array to myal. And we see then, here are the contents of the array list called myal and the number of elements. There are 8 elements there. I can add an element to my array list, which will lengthen the array list by adding this item at the end. Let's do another one of maybe 32, and we'll do one more. In this case, I'm going to add an element of string, and notice that it's part of my contents. And I can do a double value. I can also insert elements. So I can insert a value, in this case 44, at index 3. And we'll see 44 pop up there at index 3. And now I have 13 elements in my array list. Now here's where the problem comes in. I want to remove an element. And originally I was just removing an element, so I want to remove, say, 12. And I would click remove value, and nothing happened. It couldn't find 12 because it recognizes this 12 as an integer, whereas this 15 that I added, because it was coming from the text property, is actually a string. So if I change this to 15 and remove that value, notice the 15 went away. So what I ended up doing was adding some radio buttons to determine the data type that I want to remove. This is that boxing, unboxing issue that comes up, and the problem with working with non-typed data values. But if I make this an integer and I choose 12, now I can remove that value. It found it as an integer, not as a string. So here's the code that I put in. For the remove button, I did a little if else based on those radio buttons. And notice I have to set the text that I want to remove to an integer or to a double value. So if I say I want to remove 20.75, now actually I added that in as a text value, but if I choose double, it does remove it. And if I add that back and choose I want to remove it as a string, it moves it that way as well. When I transferred these in from the array as an integer value, it firmly enhanced those integers and doesn't allow me to treat them as strings. Now I can also remove an element at a particular index. So I'm going to say index 2, that's going to be my 44 in this case, and it goes away. So that's using an array list and how it can resize itself. Let's take a look at a list collection. When we declare a list, we specify the data type in the parentheses of the list of as of and whatever the data type is. So here I'm declaring zoo as a list of type string, and it's an instance of a new list of type string. This is why we call it a generic, and I can have any data type in there, including my own data types I would create as a result of the data classes that we'll create. And we'll see shortly we can create a structure as a data type. We can shorten that a little bit as dim zoo as new list of string. So I can put the new in the declaration statement rather than having equals a new list of string. And we can also populate at the same time. So we can say dim ABC as list of integer, and then in parentheses new integer as an array. So I have parentheses there being 5, 12, 8, 23, and 16. And those values would go into my list named ABC. As we did before, we can use the add command to add items into our list. And of course, I can also create a new collection and add that as a range, as we did with the array list. The advantage of the list is, again, they are dynamically sized. They will shrink and expand as needed. But the big thing is they are type safe. It is a typed collection, and that removes a lot of possibilities of error. They are not multidimensional. However, we do use structures and class instances, which are a better way of doing it than probably using multi-dimensions in an array. Lots of different methods for a list, for adding, removing, inserting. We can sort. There's even a reverse method, which is also available in the array list. We can reverse the list. And to be honest, I hardly ever use array list, but I use lists a lot. Let's take a look at an example. I've recreated the project from our array list demo to be a list demo, and I've declared a list called myList as a list of type string. And then I use the add range method in my form load to add Phoenix, Mesa, Scottsdale, and Tucson. And we see over on the right-hand side a list box where we can visually display the contents of the list. Now remember, lists are happening in memory. But this allows us to look at the values and see how many elements there are. And you see there are 4 elements as dictated at the bottom of that list box. I can add an element. Add Flagstaff. Let's add Williams. Tombstone. And I'll add in Yuma. And now my elements are 8. There are 8 cities listed in that list. I can also insert an element at a particular location. So here I'm going to insert Tempe at element 3, and we see Tempe come in as our 4th element. Remember, we start counting with 0. I can also remove a value, just specifying the contents. So I can remove Mesa, or I can remove a value at a particular location. We get rid of the value at index 2, and Tempe disappears. I can also sort the list, and now it goes from A to Z. So that's a demonstration of a list being used as a collection in memory. A common question that comes up is, how do I know when to use which type of data collection? Here's my response. I'd use an array if I just need a very simple, small, static data collection. Maybe I need the days of the week or the months of the year. That's not going to change. Or if I need something that's multidimensional, and that's going to depend on my algorithm. And in most cases, that multidimensional is probably going to be numeric as integers or double values. In array list, I would use, I want something dynamically sized. However, I hardly ever use an array list because I'm going to opt for a list in most cases. I use a list by far the most of any three of these. And so I'll certainly use a list if I need something dynamically sized, but often I'm working with data. And that data might be in the form of a structure, which we'll look at shortly, or a data class that we'll look at in creating our own object-oriented classes. Most applications have a data back end to them, and so list lends itself really well to that. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.